Dear students, today is April 29th. It's the second lesson of the sixth week. In this lesson, we're going to talk about solution. Prepare your science notebook and your stationery, and let's start. On the top of a new page of your science notebook, write the date and the title of this lesson. Our objectives for today: demonstrate an understanding of the terms solution, solvent, solute, and saturated solution. Identify substances and assess their purity from melting point and boiling point information. The keywords for this lesson are solvent, solute, solution, purity, saturated. Which of these represent a pure substance? Picture A represents an element where all atoms are alike and nothing else is added. Accordingly, A represents a pure substance. In picture C, all atoms are alike and then C is a pure substance as well. Picture D represents a compound. It's the repetition of the same pattern and nothing else is added, so D is a pure substance. Which of these represent a mixture? In picture B, I have a mix between many substances and E as well, so B and E represent mixture. Which of these represent a heterogeneous mixture? In picture B, in one place I have more black substances and in another place I have more white substances. Accordingly, the appearance isn't uniform and B represents a heterogeneous mixture. Which of these represent a homogeneous mixture? In picture E, the appearance is the same. So, E represents a homogeneous mixture. Which of these represent a solid? In a solid, particles are tightly organized closer to each other. Accordingly, C and E represent solids. Which of these represent an element? In an element, all atoms are alike, formed from the same type, and then A and C are elements. Which of these represent a compound? In D, I have two types of atoms chemically combined, and then picture D represents a compound. When you add sugar to a cup of tea, what happens to the sugar? When I add sugar to the tea, the sugar won't settle at the bottom of the liquid, won't float on the top surface, and won't be killed by the tea. The sugar will be evenly distributed all over the tea, so each tea particle will host a sugar particle, and then I say the sugar is dissolved in the tea. What will happen to the mass? When I'm adding sugar, I'm adding matter, and then these sugar particles will increase the overall mass of the cup of tea. When you add sugar to colder water, it takes longer to dissolve. Let's watch these two movies to discover why. When we have more temperature, This means that there's more kinetic energy. Particles will use this kinetic energy to move faster. Then we have more collision between water and sugar particles. Sugar will be dissolved faster. The substance being dissolved is called solute. The substance it's dissolved into is called the solvent. A mixture of a solute and a solvent is called solution. Can you draw a quick sketch of a cup of tea and write these definitions in the correct place? When I drop a tea bag in hot water, particles of tea are dissolved in hot water. So tea is the substance being dissolved, which is called solute. The tea is dissolved in what? The tea is dissolved in water. So water is the substance dissolving into, and it's called solvent. A mixture of a solute and a solvent is called solution. When I mix salt and water, salt will be dissolved in water, and I'll have a solution. Each solution is formed from two parts, the solute and the solvent. Particles of salt are small and are evenly distributed, so they'll be easily dissolved in water, and then salt is called solute. Water will dissolve the salt, so water is the solvent. In a solution, the appearance is uniform all over the mixture, and then a solution is a homogeneous mixture. Although the appearance is uniform, this never means that there's chemical bonds between the solvent and the solute. They are just closely mixed, and the salt is evenly distributed. After mixing, the water will stay water H2O and salt will stay salt. They are evenly distributed one next to the other. Other examples of solution: salt water, sugar water, and vinegar. Identify one solute and the solvent in each of the following solutions. In salt water, what's the substance which is dissolved? Salt. So salt is the solute. This salt is dissolved in what? Salt is dissolved in water, so water is the solvent. In canned lemonade juice, which substance is dissolved? Lemon juice is dissolved, so lemon juice is the solute. The lemon juice is dissolved in what? The lemon juice is dissolved in water, and then water is the solvent. What type of mixtures are solutions? Solutions are homogeneous mixtures, since the solute and the solvent are evenly distributed. Do you know that air is a solution? Air is formed from many substances mixed together, mainly nitrogen, oxygen, carbon dioxide, so air is a mixture. These substances are evenly distributed all over the mixture. And then I have a homogeneous mixture, which is a solution. If I put one or many spoons of sand in water, this sand will be suspended down at the bottom of the water, so sand is insoluble. But if I put a spoon of sugar in water, this sugar will be dissolved. Accordingly, sugar is soluble in water. What will happen if I dissolve 10 spoons of sugar in a cup of water? The sugar will settle down. But we arranged that sugar is soluble in water. Why does it settle down this time? In order to know the answer, let me ask you a question. How many pieces of pizza are you able to eat? I'm personally able to eat 3 pieces, and then I'll feel full. The extra pieces of pizza will be left aside. Similarly, the solvent is able to dissolve a limited amount of a solute. If I try to dissolve more amount of solute, the extra quantity will be settled down. So, a diluted solution contains a small amount of solute. If I'll add more solute, the solution will be concentrated. When this solution contains the maximum amount of solute, it's called saturated. So, a saturated solution contains the maximum amount of dissolved solute for a given amount of solvent at a specific temperature. Then, a solvent can't hold anymore. We mentioned that temperature must be specific. Do you think that the maximum amount of solute will change as I'll increase the temperature? In order to know, prepare yourselves to make this activity. In this activity, you're going to plan for a safe and valid experiment about the effect of temperature on the solubility of sugar, which is the solute, in water. What is solubility? Solubility is a measure of how much solute will dissolve. You will record how much sugar dissolves at different temperatures. Pause the video and plan for your experiment. You need to set the materials, the procedure, dependent variable, independent variable, and the controlled variables. What are the material needed? For sure, I need water. What do I use to have a fixed volume of water? Measuring cylinder. In what will I make the experiment? In a flask. For sure, I need sugar, the balance to measure the mass of this sugar, stirring rod to stir the sugar when I'm dissolving it in water, electrical heater to increase the temperature, and thermometer to measure the temperature. What is the procedure of my experiment? I'm going to measure 25 milliliters of water with a measuring cylinder and pour them in a flask. I'll heat the water to 30 degrees Celsius and add the sugar and stir until no more sugar will be dissolved. I record the mass of this sugar dissolved. Then I repeat the same procedure at different temperatures. When I'm making this experiment, what am I changing each time? I'm changing the temperature. Accordingly, temperature is the independent variable. What am I measuring accordingly? I'm measuring the amount of sugar dissolved, and then the amount of sugar dissolved is the dependent variable. Which variables must maintain fixed all over the experiment? I must have the same amount of water and same type of sugar, so they are the controlled variables. I made my experiment, I changed the temperature each time, and I measured the maximum amount of sugar dissolved according to each temperature. Right now, I will organize this given in a table. So here I have the table. For example, at 30 degrees Celsius, the maximum amount of sugar dissolved is 24 grams. At 80 degrees Celsius, the maximum amount of sugar dissolved is 58 grams. Right now, I'm going to transform this table into a graph. What is the independent variable? The independent variable is the temperature. So temperature will be on the x-axis. What am I measuring accordingly? I'm measuring the maximum amount of sugar dissolved in grams. So the maximum amount of sugar is the dependent variable and will be on y-axis. At 30 degrees Celsius, the maximum amount of sugar dissolved is 24 grams. So at 30 degrees, the maximum amount of sugar is 24 grams. As I'm moving two squares on x-axis, the temperature is increasing 5 degrees Celsius. As I'm moving one square on y-axis, the amount of sugar dissolved is increasing 2 grams. At 35 degrees Celsius, the maximum amount of sugar dissolved is 25 grams. So it's 35, and 25 is between 24 and 26. So from 25, I'll go up until I reach 25 grams, which is between 24 and 26. At 40 degrees Celsius, the maximum amount of sugar dissolved is 27 grams. So on 40 degrees Celsius, I'll go up until reaching 27. 27 is between 26 and 28. So I'll go up until I reach 27 and I'll put an X. At 45 degrees Celsius, the amount of sugar dissolved is 29 grams. So from 45 degrees Celsius, I'll go up until I reach 29. 29 is between 28 and 30. So I'll go up from 45 until reaching 29 and I'll put an X. Similarly, at 50 degrees, the maximum amount is 31. So from 50, I'll go up until reaching 31, which is in between 30 and 32. At 55, the amount of sugar increased till 34 grams. So at 55 degrees Celsius, I'll go up until reaching 34 and I'll put an X. Right now at 60, the amount of sugar dissolved is 33. It's 60 degrees Celsius. I'll go up until reaching 33, which is in between 32 and 34. At 65, the maximum amount of sugar dissolved is 42. So from 65, I'll go up until reaching 42 and I'll put an X. Right now, at 70, the maximum amount of sugar dissolved is 46. So it's 70 degrees Celsius. I'll go up until reaching 46 and I'll put an X. Right now, at 75 degrees Celsius, the maximum amount of sugar dissolved is 52 grams. So it's 75. I'll go up until reaching 52. So it's 52 and 75. I'll put an X. At 80 degrees Celsius, the maximum amount of sugar dissolved is 58. So it's 80 degrees Celsius and it's 58. From 80, I'll go up until reaching 58 and I'll put an X. Which result is incorrect? How do you know? At 60 degrees, the amount is 33. This value is incorrect because it's out of the pattern. Suggest one error that may have produced the incorrect value. A mistake was taking place at the level of measuring the volume of water, or measuring the mass of the sugar, or measuring the temperature of the solution. One of these mistakes might take place to give me this wrong value, which is here. What does the data tell you about the effect of temperature on solubility? The amount of solute dissolved increases as the temperature increases. So as I have more temperature, the amount of sugar dissolved is more. So as the temperature increases, as I have more sugar which is dissolved. How many keywords from today can you spot in these pictures? First, We learned that sand is insoluble, so it doesn't dissolve in water. Salt is soluble. Once salt is soluble, it will be the solute, which is dissolved in water, which is the solvent. And then I have the C, which is a solution formed from salt dissolved in water, from solute dissolved in the solvent. Coffee beans are partially soluble in water, so the coffee beans are the solute, which is dissolved in water, which is the solvent. Then I'll have the coffee, which is a solution formed from coffee beans dissolved in water. Bath bomb is the solute, which is soluble in water, so the bath water is the solvent. Then I'll have bath with salts, which is the solution. What will happen to the particles during the change of state? If you heat a solid, the particles stay the same. If I have ice, still ice is water. After melting, the ice won't turn into oil. As a result, all what happened is these particles vibrated more. As a result, they move slightly further apart, so solid expand. So the force of attraction between particles will be weakened, and then the tight organization of particles will be broken. Particles will slide past one another, and then the solid will melt, and the physical state will turn from solid to liquid. At which temperature melting will take place? Melting will take place at melting point. Melting point is the temperature at which the solid will melt. What will happen if I kept in heating this liquid? When I'm heating the liquid, the particles will absorb kinetic energy. This energy is absorbed by the particles, and then they will move faster and far from one another. And then when these particles will move faster, the physical state will turn from liquid to gas. And then this is called boiling. At which temperature boiling will take place? Boiling will take place at boiling point. Boiling point is the temperature at which a liquid will boil. Pure substances always melt and boil at fixed temperature. For example, the melting point of pure water, the distilled water, is 0 degrees Celsius, and the boiling point of distilled water is 100 degrees Celsius. So, if I have an unknown liquid and I want to know what is this liquid, if this liquid will boil at 100 degrees and will freeze it will melt at 0 degrees Celsius, so I'll be sure that this liquid is water, because there's no other pure substance that will boil at 100 degrees and will melt at 0 degrees Celsius. The room temperature is almost equal to 20 degrees Celsius. At 20 degrees Celsius is more than the melting point, so water got enough energy to melt. It will turn into liquid, but 20 degrees Celsius isn't enough for water to boil. So still this water didn't turn into gas. So 20 degrees Celsius is between 0 degrees and 100 degrees, is between the melting point and the boiling point. That's why water is liquid at room temperature. Scientists measured the boiling and melting points of all pure substances. The melting point and the boiling point have all been checked by scientists, and they are published in data books. Mixtures change the melting and boiling points. If I have substances dissolved in water, the water won't boil at 100 degrees Celsius. The boiling point will increase. You'll ask me, it will increase to which temperature? We can't know because a mixture doesn't have a fixed composition. As there are more substances dissolved in water, as the boiling point will increase. Similarly, when there are substances dissolved in water, water won't freeze at 0 degrees Celsius. As I have more substances dissolved in water, as the melting point will be less. So pure water will freeze at 0 degree. As there are more substances dissolved in water, as the freezing point will decrease. So it will be -1. If there are more substance dissolved, the melting point will decrease until -2. More substances dissolved, the melting point will decrease at -3. These numbers are examples to clarify that as there are more substances dissolved in water, as the freezing point will decrease. Already we arranged that distilled water will boil at 100 degrees Celsius. Deionized water will boil at 100.2 degrees Celsius. Tap water contains impurity and minerals dissolved in it. So, as there are substances dissolved in water, the boiling point will increase from 100 to 100.8 degrees Celsius. Right now, the boiling point of salty water is 102.5, but this temperature isn't fixed because it depends on the amount of salt which is dissolved in this water. When this water is pure, it doesn't contain any amount of salt dissolved. Pure water will dissolve at 100 degrees Celsius. When I have 20 grams of salt which are dissolved in water, the boiling point increased till 102 degrees. When the amount of salt increased till 40 grams, the boiling point increased almost 104 degrees. When I have 50 grams of salt which are dissolved, the boiling point increased. So, as I have more salt which is dissolved in water, the boiling point will increase. So, as we arranged, as you dissolve more salt in water, the boiling point gets higher, up to a limit. Why? Because already we talked about solubility, which is the maximum amount of salt that a specific amount of water is able to dissolve. So the maximum of salt dissolved is limited, and then I'll have a limited boiling point. Each pure substance has a specific melting point. As an example, the melting point of water is 0 degrees Celsius. If a substance will melt at 0 degrees Celsius, so I'll be sure that this pure substance is water. The melting point of nitrogen is different. Nitrogen will melt at -209.9 degrees Celsius, while the melting point of silver is 961.93 degrees Celsius. The melting point of carbon is 3500 degrees Celsius. Similarly, each substance has its fixed boiling point. What is boiling point? Boiling point is the temperature at which a liquid will boil, at which a liquid will turn into a gas. For example, water boils at 100 degrees Celsius. When the temperature is equal to 100 degrees Celsius, liquid water will turn into gas. As for nitrogen, the boiling point of nitrogen is minus 195.79 degrees Celsius. The boiling point of nitrogen is completely different than the boiling point of silver, which is equal to 2162 degrees Celsius. The boiling point of carbon is 4027 degrees Celsius. Accordingly, each substance has its own boiling point. The melting point of water is 0 degrees Celsius. So, when the temperature is below 0 degrees Celsius, is below the melting point, the physical state is solid, and then I have ice. When the temperature is equal to 0 degrees Celsius, this ice will start melting. When the temperature is more than the melting point, the water turned from the solid to liquid. When the temperature is more than the melting point, the water will exist as liquid state. When the temperature will increase to 100 degrees Celsius, which is the boiling point, this liquid will turn into gas. So when the temperature is more than the boiling point, water will exist as a gas, will exist as water vapor. What is the physical state of water at 45 degrees Celsius? So 45 degrees Celsius is more than the melting point, so it's a liquid, but this liquid didn't get enough energy to boil. 45 degrees Celsius is below 100 degrees, is below the boiling point, so liquid didn't get enough energy to boil. Accordingly, at 45 degrees Celsius, water is liquid. What is the physical state of water at 125 degrees Celsius? 125 degrees Celsius is more than the boiling point, is more than 100 degrees. So at 125, water got enough energy to turn into gas, and then at 125 degrees Celsius, water will exist as a gas. What is the physical state of water at minus 23 degrees Celsius? Minus 23 degrees Celsius is below the melting point, and then the physical state is solid. This temperature has to increase to 0 degrees Celsius in order to melt into liquid. As this temperature is below 0, is below the melting point, this means that water will exist as a solid. What is the physical state of water at 75 degrees Celsius? 75 degrees Celsius is between 0 and 100, is between the melting point and the boiling point. So water got enough energy to melt, so it's at the liquid state, but this liquid didn't get enough energy to boil and turning into gas. So as this temperature is between the melting point and the boiling point, water will exist as liquid at 75 degrees Celsius. To sum up, at 45 degrees Celsius, water will exist as liquid. At 125, water will exist as gas. At minus 23 degrees Celsius, water will exist as solid. At 75 degrees Celsius, water will exist as liquid. Here are the melting and boiling points of some elements. What state are they at 25 degrees Celsius? Stop this video. Write the physical state at 25 degrees Celsius according to the melting point and boiling point of each element. Then start the video again when you're ready. The melting point of chlorine is minus 101 degrees Celsius. The boiling point is minus 34 degrees Celsius. At 25 degrees Celsius, chlorine got enough energy to boil, and then it's at gas state at minus 25 degrees Celsius. Concerning iodine, the iodine will melt at 114 degrees Celsius. So the temperature has to increase to 114 degrees Celsius in order to turn into liquid. 25 degrees Celsius is below 114, is below the melting point. So this means that iodine didn't get enough energy to melt at 25 degrees Celsius, and then iodine will exist as a solid at 25 degrees Celsius. Concerning fluorine, fluorine will boil at minus 188 degrees Celsius. So 25 degrees Celsius is more than the boiling point, and then fluorine got enough energy to boil and turning into gas at 25 degrees Celsius. So at this temperature, 25 degrees Celsius, fluorine will exist as a gas. What about bromine? Bromine will melt at minus 7 and boil at 59 degrees Celsius. 25 degrees Celsius is between the melting point and the boiling point. So at 25 degrees Celsius, bromine got enough energy to melt, but it didn't get enough energy to boil. And then bromine is liquid at 25 degrees Celsius. Right now, you're going to write the physical state of these elements at minus 50 degrees Celsius. Pause the video, write your answers, then start it again when you're ready. Let's start. Minus 50 degrees Celsius is between minus 101 and minus 35. So at this degree, chlorine got enough energy to melt, but it didn't get enough energy to boil. And then at this temperature, chlorine is liquid. Already it melted at minus 50 degrees, but it didn't get enough energy to boil and turning into gas. What about iodine? At minus 50 degrees is less than the melting point. So at minus 50 degrees, iodine is at solid state. It didn't reach the melting point in order to melt and turning into liquid. So iodine is solid at minus 50 degrees Celsius. What about fluorine at minus 50 degrees Celsius? Minus 50 degrees Celsius is here, is more than the boiling point. And then fluorine got enough energy to boil and turning into gas at minus 50 degrees Celsius. So fluorine is a gas at minus 50 degrees Celsius. What about bromine? Minus 50 degrees Celsius is under minus 7, is under the melting point, which means that at minus 50 degrees Celsius, bromine didn't get enough energy to melt, and then bromine is solid at this temperature. Thank you for watching. Respond to the questions of the assignment sheet posted on Edmodo. Don't hesitate to send me any question you may have on Edmodo. Thank you for watching.